The use of optical in sensing device is widely used nowadays. This is because it provides a lot of advantages such as lightweight, immune to EM wave, and high sensitivity. A lot of device or sensor these days that use the principle of optical sensing principle, such as temperature sensor as well as strength sensor. The conventional method that is used to measure temperature that we usually use is such as thermocouple, thermistor, junction temperature sensor. However, this sensor has its limitation, which can be overcome by using optical sensor such as blackbody radiation and interferometric. The most popular sensor used is fiber break grating. It uses the principle of modulation wavelength.
It is important to understand how the principle works in the fiber break grating operation. Break wavelength is used as FBG required specified wavelength. As the temperature changes, the wavelength will shift. A variation of temperature will lead to the variation in spectral period of grating and in refractive index of material. The variation in refractive index of the material play important role of the wavelength shift due to the thermal expansion.
The basic setup to examine the performance of single-mode temperature sensor is illustrated as the figure shown. The fiber is a single-mode fiber fabricated and the light-emitting diode is used as the optical source. The light-emitting diode operates at 1310 nanometer. Firstly, the light exiting the LED goes to a 3 dB directional coupler in which one port is terminated by matching oil. Light exiting the main exit port goes to the single-mode fiber with a fiber break grating inscribed in it. The fiber ends at matching oil in such a way that all the transmitted light through the grating is absorbed by the oil. The reflected light by the grating returns to the coupler and part of this light is observed at the optical spectrum analyzer or OSA. The fiber break grating is heated by the heating plate until it reaches a temperature of 90 degrees Celsius. The temperature is sampled by a diode sensor which feed back the temperature information to the heating plate's controllers in order to stabilize the temperature. The single-mode fiber with the grating is inserted in the aluminium slab which works as thermal capacitor, is decreasing the interference of the environment and making the temperature variation slower. After reaching the temperature of 90 degrees, the heating plate is turned off and data acquisition begins, with the temperature being monitored by the diode sensor. The temperature decay is slowed by the aluminium slab, what permits a more accurate acquisition. The data acquisition or the peak wavelength of the loops and block temperature is automated by using a LabVIEW software. The data occurring during 2-minute interval providing a large number of points.
FBG used as a sensor for temperature and strain due to their important characteristic, which is small in size, compactness, high sensitivity, and simplicity to fabrication. Plus, FBG sensor is immunity to electromagnetic noise, where FBG sensor can monitor temperature directly inside a transformer precisely.